Very typical question on the SAT deals with ratios regarding similar shapes. So I'm just going to use a square as an example. And let's pretend I drew these nicely. Let's say these are two squares. And let's say they have a ratio of length of 2 to 5. We can basically make a ratio table. And first we have lengths have a ratio of 2 to 5, small to big. What would the ratio of the areas be? In this case, it'd be easy to calculate them, right? Since it's a square, this would be 4 and this would be 25. But another way to get that would just be to take the ratio of the lengths and to square each term. So let's say now instead of squares, I gave you three-dimensional figures, and these in fact were cubes. How do you think we get the volume ratio? Again, we take the length ratios. This time we would cube them. Now let's see why this is helpful. Squares and cubes are pretty easy to deal with, but let's say they give you a shape where you don't necessarily know the volume formula. Let's say these are two similar pyramids, and I give you that this face to that face has a ratio of, again, let's just say 16 to 25. In order to, and then I want to figure out what the volume ratio is. In order to do that, we first need to convert back down to the length ratios. We don't really need to calculate what one of the lengths is using 1/2 base times height, because again, we wouldn't know each of the dimensions, right? We could plug in a value for b and h and that would work, but we don't even have to go that far. Here we went from the length ratio, squared it to get the area ratio. So to go in the reverse direction, we would take the square root of the area ratio to get the length ratio. So this would be the root of 16 to the root of 25, or we get 4 to 25. Now to go from the length ratio to the volume ratio, we cube it. So we get 4 cubed to 25 cubed. So you see it's a lot easier doing it this way, especially when you have irregular shapes. In some cases, you might get a shape that looks like this, like a piece of toast maybe. And let's say that these are similar shapes, and I give you this length is 3 and this length is 4. How would you figure out the ratio of the areas? Again, we don't actually have to find the areas of both. If we know that the length ratio is 3 to 4, then the area ratio will just simply be 3 squared to 4 squared, or 9 to 16. So hopefully you found this helpful. Make sure that whenever you have similar shapes and they're asking you ratios, whether they're lengths, areas, or volumes, you use these relationships. Remember, you always have to go to the lengths first, square it to go to the area ratios. You cube the length ratios to get the volume ratios, but you can't just take the square root to go back down to go back from volume to area and vice versa. So hopefully that helps.